Hello everyone. Welcome to our today's webinar on future of cities, SuperMap GIS boast smart technologies. We have our special guest speaker with us, Dr. Asif Ahmed, Assistant Professor, Department of Geography and Environment, University of Dhaka, and I am Wadur Rahman, Technical Support Engineer from SuperMap Asia and Oceania Center. Again, welcoming you all in our today's webinar. In today's webinar, we will demonstrate the topic on future of cities, SuperMap GIS boast smart technologies. So, first of all, I would like to give the floor to our guest speaker, Honorable Sir Dr. Asif Ahmed, Assistant Professor, Department of Geography and Environment, University of Dhaka, to give us small talk regarding the GIS, remote sensing, emerging technologies which we can use to boost our transportation system, as this is one of the most emerging topic in today's world. So, sir, can you?
Hello. Thank you, Mr. Wadur Rahman. Thank you, everybody, for joining us. This is a very special moment for us who are working on GIS and remote sensing, or who are using geoinformatics for problem solution, so soluting in problems. So in this occasion, or in this special webinar, I would like to also thank to SuperMap for arranging this kind of special events. And the topic, especially the topic, is very important for our day-to-day life, because we have a lot of problems with transportation system in the world, and but still we have some options, and which we can explore, and by using this emerging technology, we can solve this kind of problems. Here I'm also thanking everybody from different sectors. Some are from say like universities, some are from different organizations. But the thing is, we all know that the problem is about transportation. We everybody use transportation in our day-to-day life. That's why if we can realize the problem first, then this is our responsibility, those who are working in academic arena, how we can solve this kind of problem. So that's why we have chosen this topic, that in future what our cities what type of dimensions of the cities can be in future, and in that situation what type of transportation systems we need, and how GIS and remote sensing or SuperMap technologies or smart technologies can help us. So I have the opportunity of gaining some experience of first world countries about their transportation systems and their technologies. So what I have seen there, what knowledge I have in there, that they are in a different stage right now, and what we have the problems in our country or in this subcontinent, they don't have this kind of problem, but they're much more advanced in this kind of using this kind of technologies to solve this kind of problem. So they have a different kind of technologies that they are dealing with. So in this special webinar, our demonstrator, Mr. Wadur Rahman, will give you some insights into solution, into identifying the problems, and then how we can solve this kind of problems. So the main goal of our webinar is to find the solutions actually. So what we need actually in this city life or day-to-day life, we don't want traffic congestion. We don't want to waste our time in on road. We want to reach on time. This is the main thing. So Based on this theme, the first world countries or the third world countries or the developing countries are trying to identifying different models, how we can rearrange, how we can reshuffle our transportation, urban transportation system. So in association with this kind of transportation system, we also have different kinds of related problems, say like related with this kind of transportation, for example, urban crime, and policing actually. So and then emergency services, and then the urban network services. So including all these things, what we have this kind of technologies in our hand that we can use for future generations. So that's why our topic is future of cities. Future of cities means in what type of cities we need in future, and based on that aim, how we can design our transportation system, and how we can model our transportation system, and how we can implement in the real world situations. So sometimes the thing is that sometimes we can model this kind of system in say like by using our smart technologies, but in reality what can be happened in reality, we don't want we normally sometimes we don't find the validation check in the field in real world. That's why this is important to assess the real world situation as well in this kind of model. So today what SuperMap can do for this kind of transportation smart by developing a smart transportation system that will be demonstrated by our demonstrator Mr. Obaidur Rahman. So I think if Obaidur can start on this kind of lecture on this kind of topic, then we can share with our views and then we can gain some knowledge from this kind of demonstration. So right now this is a very short and very informal talk from my side, and let's see what Obaidur Rahman presents to us. Thank you very much.
Thank you so much, sir, for valuable present talk, and let's move on to our demonstration for today's webinar on future of cities, SuperMap GIS post smart transportation. So I'm here, Ubaidur Rahman, technical support engineer from SuperMap Asia and Oceania Center. So the presentation will be introduced from the following aspects. The first one is how to construct basic transportation of GIS application system. The next one, we are going to learn about how to further construct more complete system of transportation business. We call it Transportation One Map platform. Then because of the 3D technology development, here we will talk about why transportation construction needs 3D technology and what 3D technology can do in transportation construction. At last, but not least, with the development of big data, we are going to talk about how to integrate transportation construction with big data technology. So now, firstly, let's look how to construct basic transportation GIS system platform. Firstly, let's have a look why the system needs to be improved. So there are many other businesses, applications needs to be integrated in the system. Railway business, aviation business, travel business, post, logistics, etc. are all involved in transportation. Each of them has their own business requirements. So how to assist the industry to share and integrate special geographic information resources, how to integrate the various business application into one system, and how to save the construction cost of industry, spatial data management, improve the quality of data service and user experience. So let's also see what are the challenges of transportation GIS. Firstly, with more and more GIS data generated, how to manage, store, and update the increasing information. There is also a large number of repeated and decentralized spatial information and how to optimize it. In addition, there is a lack of unfilled standard for the management of space information and a lack of space information sharing mechanisms and techniques. The last challenge is that with the development of Internet electronic map, how to construct a system that more professional, more reliable, and also more practical applications. So with these questions, here we propose DIKW model to solve Deepening Industry Application. It is a development mode from data to wisdom. First of all, here you can see the data, information, knowledge, and wisdom. In the traditional way, we always solve problems according to the data we have. So we can only do a few applications around the data. But if you further integrate the data, extract the valuable information, we can do much more applications. With the new development mode, here we propose transportation one map. So which can integrate transportation industries, special resources, provide application foundation of transport special information, and be platform and also be a platform of special information sharing within the transportation industries. So first of all, let's look at the system architecture of transportation service platform. All the system cannot be constructed without hardware, equipment, and software. The second and most important layer is data management. Data is the soul of GIS. So there are various data related to transportation, including special data and non-special data. All this data needs to be processed, classified, stored based on a certain data standard. Different types of data needs different storage. The next one is what kind of services need to be used for developing applications. It is based on requirements of systems. The basic applications of transport GIS system should be realized: route network management, traffic facility management, statistics of various data, road design, navigation, emergency reporting. And we may need these services for these functions like map service, data service, and some special analysis services, such as network analysis service, special query service. The last layer is user layer. We need to know which terminals should be used, who will use this system, and all these modules from a complete system. The next one, we are going to further learn about how to construct more complete system of transportation business. So the picture shows how to realize information, special spacing based on one map. The first level is City Department of Transport, which provides local transport thematic data, road network, railway network. The second level is Province Department, which aggregate the provincial traffic thematic data. The last level is National Department, which aggregates national traffic thematic data. So the main ideas of transportation is one map can be understood like this. The business information integration of each region can be spliced in space to achieve a complete picture. This vertical business integration and horizontal region is placing spatial information framework is called one map. So the steps to realize one map integration are data collection, information integration, service sharing, and finally realizing the intelligent management through cloud technology. So based on the above ideas, we have developed the one open framework product of one map and formulated the standard system. Traditional mode is to develop a specific business for a requirement. This new platform integrates multiple industries into one system through a unified GIS management platform, which is effectively improved resource utilization and sharing. The next, let's look at what the platform should be built. The content includes three aspects actually: the standard construction, data construction, and system construction. Let's firstly have a look how to realize standard construction. So there are three parts actually: management specification, data specification, and service specification. The core construction is data specification. This part mainly discusses how to standardize different types of data. For vector data, grid data, attribute data, and other data, we need to standardize them. And then, according to the data, management method and core metadata standard of OneMap establish the data classification system of OneMap. Then the data classification system is divided into information service, graphic mode, and interface, and their respective specifications are established to generate service sharing specifications. Besides, the management specification can be established by creating data documents specification and data backup specification, so as to achieve the OneMap standard system construction. The core is how to convert data to service. Each industry data has its own set of data, so we provide classified storage based on the data standard. Each industry data can be divided into general special data and industry private special data. And general special data can be integrated to one general special data and one traffic public special data. Finally, there are three types of database: Compose, Transportation Geographic Information Data Platform. Compose, Transportation Geographic Information Data Platform, General Special Data, which store basic geographic data, Traffic Public Special Data, which stores the traffic thematic data, and all the industry private special data. So the next step is to realize the construction of transportation service platform after data classification. Firstly, we need to know the user layer. Okay. Firstly, we need to know the user layer, who will use the service and what they want to do with the services. Like the business department, they want to provide comprehensive functional services, integrate special system, and develop framework SDK. And the decision-making departments wants to realize the special presentation of data mining and data special statistical analysis of traffic. The public needs detailed and accurate travel services as well as real-time traffic information. And therefore, we firstly need to publish static data as GIS general service to provide the basic functional services. Then the dynamic data is published as data or information publishing service, providing real-time services. We also need to publish data mining result as professional transportation services, providing statistical services and analysis services. Through data management and service management, OneMap system is built to realize the application of users. Through data management and service management, OneMap system is built to realize the application to users and generate standard application services at the same time. Each level is based on its according or corresponding standards. So firstly, the platform will perform three types of service application: the map service, the data service, and and also the functional services. This application can be obtained by accessing the platform. Each service corresponds its function to meet the requirement of different user. The platform provides 3 types of services, which can be obtained by accessing the platform and do not need to be built by yourself. Comprehensive emergency response for highway and waterway, public traffic service, market credit management, operation monitoring, early warning and decision analysis, urban transport passenger traffic, urban transport passenger, transport hub and regional logistics. So firstly, let's look at how to integrate multi-source data in a system. We can integrate the spatial geographic data in a map by thematic map. Data for each category can be displayed on a map as a layer, and each layer can be controlled through layer management and scale. Here you can see the different types of data sets or different sources like POI or place name, administrative division, route network, digital elevation model, route ID, river, remote image, and also the railway. And they integrated in a single platform. Besides, facilities information is usually saved in the form of documents. GIS can realize visual management of facilities after symbolization and associate the attributes with special information of facilities. Users can easily query the status and information of various facilities on the map and clearly understand the spatial distribution of them. So here you can see the files containing the latitude and longitudinal information like coordinates and the point research generation and the marker symbolization, creating a thematic map, which showing the service area, overpass, oil station, toll station, camera, and also the speed limit sign. So GIS can realize the spatial query and attribute query of all the spatial elements. The platform supports the key of keyword query and also support the click of query element details on the map. The system can provide the special statistical function of traffic management data or thematic data and display it on the map in the form of thematic chart, such as route length statistics, construction fund statistics, maintenance cost statistics, traffic flow statistics, transport statistics, and so on. So here you can see the network analysis is actually basic analysis in GIS, which can realize path design of two location and list all the roads available. It can be shortest roads or the road cost least time. At the same time, with the mobile application development, road navigation between 2 points can be realized. For the problems found in the process of petrol inspection, professionals can input the detailed information, location, and level and other information of the problems through the mobile terminal for reporting. So at the same time, the reported issues are stored in a specialized database, which can be displayed and managed in the platform. The issue management status can be checked on the map. The red icons here you can see represent issues that have been submitted but not fixed. The yellow icons means the issues are being solved, and the green icons indicate that the problems have been solved and passed the acceptance. Besides, user can check the details of every events. Based on modern detection methods and comprehensive route condition data, SuperMap GIS can significantly or scientifically diagnose the causes of pavement disease, reasonably determine the maintenance reports of the design objects, and divide the design units. The complete set of maintenance design scheme includes maintenance construction plan, material allocation plan, maintenance personnel allocation plan, and maintenance fund allocation plan. The maintenance plan can be prepared on an annual basis for a multi-layer maintenance plan or according to a special event to prepare an emergency maintenance plan. And here the association will be the 2D, 3D, and graphic attributes datasets. So the emergency reporting. For emergencies, GPS is used to locate the incident. User can quickly find all the information, assist multimedia means such as photographing, handwriting, audio, etc. Clearly display the site status, so as to realize the real-time report based on mobile network. So, and on the other hand, connecting to the background, and it received the inspection task issued by the background or find problems during the inspection process. Use GPS to look at the location, quickly fill in forms, assist with multimedia methods such as photography, hand painting, audio, to clearly display on the site status and based on mobile network real-time reporting. Here, let's look at the case of OneMap application. This is OneMap platform of Jeonju Province Transportation. The home page integrates with data sharing module, service management module, public information publishing module, and provides application interfaces of resource center, development center, map center, and application center. So all businesses application are integrated into application centers, and including road application, railway application, airport application, public traffic application, port application, and so on. So here is another one. The second case is Traffic Emergency Command Platform of Xinjiang Province of China. This system not only integrates information sharing and application, but also provides emergency reporting and handling, as well as command and dispatching. So let's move on to the transportation. OneMap is already complete platform. The next we are going to talk about how to optimize transportation construction with 3D technology. So firstly, why we need 3D technology actually. Why we need the three-dimensional technology in GIS. So at present, many 3D entities have been found in the main roads, bridge, tunnels, and culverts. Especially the main connecting lines and the road around the city are mostly complex overpasses. And we lack effective 3D display means. Traditional maintenance is mostly based on the management and application of 2D plane vector data, lacking the ability to restore the terrain around the road to 3D scene and cooperate with emergency rescue to develop an overall situation. So what we need actually, we need 3D technology to display the 3D entities and make an overall solution with 3D analysis. Most of the traditional maintenance is based on the management application of two-dimensional place vector data. In the face of frequent natural disaster, it lacks the ability to restore the terrain around the road into a three-dimensional scene and formulate an overall situation or solution for emergency rescue. At present, the main road, bridge, tunnel, and culverts have formed many three-dimensional entities, especially the main connecting lines and roads around the city are mostly complex interchanges, and we still lack effective three-dimensional display method. So SuperMap 3D and 2D integration technology, real space can manage 2D and 3D data in a unified way in the background and comprehensively display 2D and 3D data on one platform in the foreground. And it can have interfaces to accept remote sensing image data and 3D terrain data in multiple formats. It can effectively display the analysis and query display under the 3D scene, and can track and pay attention to the surrounding peripheral factors that affect the highway and auxiliary facilities. Based on SuperMap real space technology, 3D scene of traffic facilities can be easily and quickly constructed, and it can effectively cooperate with business analysis functions. So here you can see that let's look at some how 3D GIS assists of transport construction. Firstly, 3D GIS provides better visualization of reality seen actually. We can view the sky, the object on the road or ground, and even object underground at the same time. It also solves practical problems such as the height design of overpass and display interior space such as the tunnel model. Meanwhile, 3D technology makes the intelligent scene as possible. You may wonder what kind of 3D data or model are supported. Here list some 3D models like oblique photography model, BIM, which is building information modeling, point cloud, and 3D terrain, fine model, etc. All are supported to integrate with GIS. So the way to match multi-source 3D data is converting 3D model data format to a GIS tool accessible. The model integrity, attributes, and consistency between graph and model need to be ensured after data fusion. Each model is added to the scene as a layer. And here, let's see some cases of 3D model fusion. The first one is the integration of 2D vector data of 2D vector line actually with oblique photography by 3D symbolization. The first one is integration. Here you can see the integration of 2D vector line data with 3D oblique photogrammetry by 3D symbolization using SuperMap. So this is the mind-blowing technology. And this is the integration of 3D model of professional modeling software and GIS. This video shows the integration of BIM with oblique photography, 3D terrain, image, and other geographic datasets. The status of the viaduct under construction and work site, as well as the terrain around it, is vividly displayed here. So 3D GIS also provides many analysis function actually. There are 4 aspects. The first operation is 3D spatial expression, which not only display the realistic object, but also the shadow body, visible body, and skyline, etc. The second aspect of 3D functional operation is which includes spatial operation, spatial relation judging, spatial analysis, and 3D measurement. 3D data can be converted to 2D and can realize 3D print as well as volume computing. And customized development is also supported with WebGL. Here you can see the spatial operation, relation analysis, and also the measurement and the customized development like convert from 2D to 3D, 3D print, volume, and surface area. Okay. Here are the result of 3D analysis like 3D slope and aspect analysis, profile analysis, 3D isoline analysis, and 3D buffer analysis. So the minimal vertical clearance often needs to be sure in the design stage. The 3D model can well display and measure the value. The tunnel body model is built by convex hull, and the special operation between convex hull and mountain body is realized to dig the tunnel. So three-dimensional analysis can realize some 3D spatial relationship queries and judge the relationship between two spatial entities, including content, disjoint, overlap, and intersection. The example shows the intersection result of subway and building. The buildings that intersect the subway are highlight display. Okay. Here's the urban rail transit construction platform. And in the practical application, integrated 2D and 3D technology, the system can display 2D and 3D integration scene, view the overall status with 2D view. Meanwhile, display core construction scene with 3D model, monitor the construction status, check risk sources, query, and highlight the resources, all of them in a single platform. Meanwhile, in the mobile terminal, it can realize 2D and 3D integrated visualization and 2D and 3D integrated navigation, as well as indoor and outdoor integrated navigation. Now, finally, let's look at the application of big data in traffic development. First of all, we need to briefly know what constitutes the big data GIS technology system. Cross-platform GIS and cloud GIS are the basic technology of big data GIS. The core technology of SuperMap big data are big data storage management, distributed analysis, stream data, and big data visualization. We already know the diversity of traffic data resource sources, actually. But how to store the growing amount of basic geographic data and thematic data? How to highly efficiently display all of these data sets? So first, we need the digitalization of basic traffic data like route network with different grades of roads, traffic equipments and facilities, traffic status are plotted on the GIS map. Secondly, the attribute information input like traffic area attribute dataset, road network attribute database, facility attribute database, traffic flow, road grade, road surface condition, image data such as aerial imagery, facility photos, etc. And thirdly, the vector grid integrated display. The raster display function enables GIS to include picture and other images, can perform overlay analysis on the corresponding attribute data to update the layers. After that, 2D and 3D integrated display. And finally, road network or facility and equipment management. The system provides editing of traffic road network, such as modification of route sections, adding and deleting route section, functions such as adding or deleting route nodes, merging or deleting route segment, etc. Dynamic segmentation technology is used in road network management. The dynamic segmentation function is to segment the connection in the map network according to their characteristics. SuperMap provides the SDE web engine and also the multiple distributed SDX to solve the storage issue of big data. Let's take a look at the result of amount of 450 million line data based on age-based storage. It is displayed smoothly in the system actually. So here you can see the application of big data. So the big data analysis operators based on SuperMap and Spark. SuperMap and Spark are growing actually. SuperMap provides different analysis operators for 4 different types of data set. Based on these analysis operators, the result of big data analysis can be displayed in a deeper level. And it supports distributed machine learning operators like random forest or clustering. And the new function of constructing the area grid is added for vector-based big data analysis. And raster big data analysis adds point density analysis. Here, like OD analysis or the origin and destination analysis. And the principle of OD analysis is to mine and analyze the starting and ending points of traffic and connection degree between stations from big data. The video shows the comparison of morning and evening peak flow between two subway stations of Beijing, China. And the principal explanation, like mining and analyzing the starting and ending points of traffic from big data, as well as degree of connection between stations such as number of passes. And the application scenarios like taxi data analyze the degree of connection between districts and countries, which are population input areas, and which are population outflow areas. So it is planned to build a road across the whole area, and all influence land particles need to be found out. This example shows the display of large number of land parcel with 10 distributed cluster. Then do buffer analysis and overlay analysis to calculate the occupied land parcel, which only takes less than 45 seconds. And plan to build a road across the entire area, you need to check all the impacts patches. Like overlay analysis, which refers to constructing filter condition based on the spatial position relationship between the geometric objects and query objects that meet the filter conditions from existing datasets. And integrated with the IoT technology, Big Data GIS can realize real-time monitoring through streaming data service and distributed service, as well as big data analysis. And it combine the front, provide the GIS plus IoT solution. And firstly, there are a streaming service to deal with real-time data capabilities, like supported by mainstream IoT. And secondly, the stored data, distributed analysis, and mining, which are like differentiated and advantages of GIS platform emphasizes our value. In this example, real-time query of route construction is realized based on distributed storage and big data analysis by accessing the real-time traffic flow data. Here, this video shows the statistics of taxis get-off points in the evening rush hour based on big data hotspot analysis. And based on taxi data, analyze the contact degree of each district and country, where are population input areas and where are population outflow areas. Taxi data analyze the degree of connection between districts and countries, which are population input areas and which are population outflow areas actually. And this video shows the number of global airplane in a certain period of time based on big data aggregation analysis. So this was the total demonstration of our today's webinar. If you have any question or query regarding anything, you can contact us, or we are looking for our partner distributor all over the world. And if you are interested, you can contact us through this email like supermapbangladesh@gmail.com, or supermap@gmail.com, or supermap.com. Thank you everyone for joining in our today's webinar.